Welcome to War Bonnet Trains. Today we're going to cover a subject that I see happen all too often. I mean, I'll go to train shows, I buy these locomotives for $5, $10 because they're not running. Most of the time they have a complaint of smoke coming out of the motor. Motor's overheating. It quits running after a couple of minutes of running. It slows down. Has a heavy drain on the power supplies. 90% of the time, it's the motor. And we'll go through the problem on this next repair. Here we go. The item we're working on today is ConCor's J-3A, manufactured by Kato back in 1975, mid-70s, right around there. The symptoms of this locomotive was overheating motor. It would run for approximately a minute or two and then stop, causing a heavy drain on the transformer. So basically what we're going to do is we're going to start out with removing the shell and getting into the mechanism and make sure the mechanism is a-okay before we actually blame the motor. So here we go. Okay, what we're going to cover here are a couple of things that you have to pay attention to during reassembly. I left them out to keep the video short, so here we go. The first thing when you're putting the frame back together of the engine, you want to make sure the motor is oriented correctly. What I mean by that is a motor can actually be installed upside down. If this happens, one of three things will happen. What you're going to get is the motor will run, but the engine is going to run backwards compared to what it used to. In other words, if you put two engines together, one engine is going to pull forward, one engine is going to pull backwards. So that's one thing. The other thing is the motor tabs might be in the wrong spot. So what's going to happen is it's either not going to touch where it's supposed to and not run at all, or it's going to touch something it's not supposed to and it's going to short. So keep that in mind. The second thing is the solder tabs, soldering the wire to the tabs. I unsoldered mine because it was easier to take the video to do the work on the motor off the locomotive. So unsoldering for me was easier. So make sure you solder the wires to the correct tab that it came off of, or the same thing is going to happen. The engine is going to run backwards if it's put in incorrectly. The third thing, the drivers. The drivers you want to install timed correctly. And what I mean by timed is the counterweights need to all face the same direction. So if you have one pointed 90 degrees, you want them all pointed 90 degrees. Because if you don't, the driver is going to bind. If one of the drivers are off so much as one tooth, it's going to run for about half a turn and stop. It's going to bind up. So those you want to make sure you have timed correctly. Okay, in the second half of this, let's go over why this happened in the first place. This engine, being a Kato engine, they make some of the best motors out as far as model railroading is concerned. Their motors are bulletproof. This engine, this is the first brush replacement that it's gone through, and this motor's over 30, between 30 35 years old. So they are tried and true. This engine without a flywheel is one of the smoothest engines out. And this was made back in the mid-70s, so it tells you where Kato was and where it is now, even from back then. So their motor technology has improved even since this model by leaps and bounds. So what caused this problem? Well, this particular engine had metal debris issues. Somewhere on this locomotive, somewhere on the layout, it picked up some metal debris, and the motor having a magnet in it that stuck and was sucked into the motor. The debris caused shorting, intermittent shorting, because the rotor was spinning. It would short sometimes and sometimes not. Debris would move around, but at one point, a piece of metal got stuck where it shouldn't have and caused a high current draw through the motor. So what happened? With a high current draw, these springs are very, very fine metal, and what happened was it overheated. And when it overheated, the spring lost its tension. It no longer kept the pressure of the brush onto the armature like it should. And what's happening is, as the rotor spins, the armature is now bouncing off the rotor. It's kind of ramping off and touching back on the rotor. Now, what is this causing? It's causing arcing, and the arcing is where the heat comes in. So it's kind of a catch-22. The more it arcs, the hotter it gets, the less the spring tension happens, and it just cascades into where the point is that there's no more spring tension at all. The brush stays off the rotor, and the motor just quits altogether. Okay. So what causes this other than that? What are other causes? The other things are motor failures can be done by having too much train on a locomotive. What I mean by that is you're got to put a lot of voltage to the motor to get it to pull a long train. You're creating a high current draw, and eventually, over a long period of time, the motor's going to get hot. Your springs on your brushes are going to lose their tension, and it's it doesn't happen all at once, but it's going to happen over time. Things like train shows. If you're running a train show all day, bring several sets of locomotive. Only run each set for a couple of hours. Take them off, because they're going to get hot. You're going to lose your brush tension, and your motor's going to start failing right at that point. Okay. So the next thing, running your trains too fast. I know it's a kid thing. We all have it. Some of us like to run our trains like when we had Lionel trains. They just run wide open and they just scream around the layout. Well, unfortunately, with these tiny motors, that's bad for The speed, the inertia of the rotor does the same thing. It causes those brushes to bounce off the rotor due to the high speed. It's going to cause a big amount of arcing. Just try this with a motor that's out of a locomotive. Just hook it up to some terminals and watch what happens. Go ahead and spin the motor at a slow speed. You'll find that it spins virtually nothing out of the ordinary. As you start getting above halfway up, as far as from 0 to full on your transformer, once you get near halfway and above that, you're going to start seeing sparks on the coming off of the rotor. And this is what we're talking about. The brushes are going to start bouncing off that rotor. The sparks, it happens, it cascades. It happens slowly, but the more it sparks, the more heat it collects. The more heat it collects, it's going to start to transfer the heat to the spring. The spring, because of the heat, it's going to start losing its tension, and then the motor will start failing from there. The more the tension it loses, the more and faster the heat is created in the motor, and it will get so hot to the point it's going to quit running. It's only going to take a minute or two around the track, and you're going to find that thing is just smoking hot, and it just stops running. Okay. Another thing that causes this, mechanism resistance. You could have several things. The mechanism could be dirty. There could be something physically locking the mechanism in the locomotive. Which comes to the last thing is what we call locked rotor. What I mean by that is you're putting power to the locomotive, and it's not that it's just sitting there spinning its tires, but the wheels are stopped. You have voltage and current going through the motor, but the motor is not spinning. This is a state where the motor pulls the most current, and you'll find most engines, and this is how the DCC manufacturers get their current rating, because if you got a motor that's locked, it's pulling a lot of current, sometimes as much as 1.5 amps. And that's why you're going to find most of your decoders are maxed out right between 1 amp and 1.5 amps. Locked rotor for a long period of time will wreck the brush springs. So that again as well, you're going to have a very short-lived motor in that state. Okay, and last but not least, this is a big controversy over how DCC works with DC locomotives. This particular motor does not have a decoder in it. So if you decided to run it on 00 on a DCC layout, this is what happens. If the engine is running, not so much happens, but if you have an engine sitting still, if you put your ear next to it, you're going to hear a buzzing noise, and that's because what you're hearing is the motor cycling back and forth, lightning fast. You can't see it, but you can hear it. And that motor, because of the way DCC is a square wave AC. And as the square wave heads up, the motor really slowly is going to start shifting one way, and as the square wave heads down below 0, it's going to go back, and that's how it stays not stopped. It stays not moving. But what happens is over time, as the engine sits there, it starts to collect heat, because ever so slightly that motor is just racking back and forth, back and forth, back and forth, and that's where the buzzing noise is coming from. You're hearing that motor shifting back and forth at a real high rate. So the longer it sits there not moving, the more heat it collects. If it's moving, the frequency is a lot higher. What happens is since it's a lot higher, the motor will run cooler, since it's actually moving in a direction, either forward or reverse, it doesn't matter. But when it sits still is where the damage is done. Now again, it's not going to happen right away. Now I've seen some engines, some older Bachmann engines that had the 3-pole motors. It is motor death. I've seen them on the DCC track trying to run 00, and as soon as you put them on the track and turn it on, it doesn't take but 20 seconds, the motor's smoking, because it just collects so much heat. 5-pole motors, they're not affected as much, but if you grab one that's been sitting on the track for a while, they're pretty warm. So heat is a bad thing for a motor. So how to correct this? One, For the first thing, too much train. Make sure you have enough locomotives on your train. I know sometimes when you're pulling 50 cars in a real train, you know, 2 locomotives plenty. On a model train, 3, maybe 4 locomotives, and that way your load is shared by 4 motors. Okay. Running too fast, slow them down. That's all there is to it. Just slow them down. Your trains will last longer. I got trains here that I've run. I've got them since the early 70s. I run them all the time. A lot of them still are the old 3-pole motors, and they run just fine. Just run them slow. Locked rotor. If you have a locomotive on the track that is not moving, turn the power off right away. Don't let it sit there and get hot. It doesn't take long, it'll burn up. Okay, and just limit your time on DCC layouts. That's really all it is to it. I know they say they can do it, which it can and it will, but the heat does accumulate at a faster rate on DCC. So with that said, I hope you enjoyed this video. Make sure you subscribe and hit the like button. And if you like to see more of these, just make sure you come back and check it out. This is the first video I've made in a long, long time. I've had some issues, some deaths in the family that I had to take care of. But I hope that with this, I'll get back into video making. So y'all have a good one.